Natural language processing, NLP, is a branch of artificial intelligence that focuses on the interaction between computers and humans through natural language. The goal is to enable computers to understand, interpret, and generate human language in a way that is both meaningful and useful. NLP encompasses a range of tasks, including text translation, sentiment analysis, speech recognition, and more. In this presentation, we will delve into the specific challenge of translating text into multiple languages simultaneously, exploring the techniques, tools, and challenges involved. In our increasingly globalized world, the ability to communicate across language barriers is more important than ever. Multilingual translation allows businesses to reach a wider audience, facilitates international collaboration, and helps preserve cultural diversity. For instance, a company launching a product in multiple countries needs to ensure that their marketing materials are accurately translated to resonate with local audiences. Similarly, academic research can have a broader impact if it is accessible in multiple languages. Effective multilingual translation is thus a critical component of modern communication strategies. Translating text into multiple languages simultaneously presents several challenges. One major issue is the complexity of languages themselves. Each language has its own syntax, grammar, and idiomatic expressions. Additionally, cultural nuances can affect how a message is perceived. Another challenge is maintaining consistency across translations, especially when dealing with large volumes of text. Machine translation systems must also handle ambiguous words and phrases that can have different meanings depending on the context. Addressing these challenges requires sophisticated algorithms and extensive linguistic databases. Machine learning plays a pivotal role in modern translation systems. By training models on vast amounts of bilingual text, these systems can learn to predict the most likely translation for a given input. Techniques such as neural machine translation, NMT, have significantly improved the accuracy and fluency of translations. NMT models use deep learning to capture the nuances of language, making them more effective than traditional rule-based systems. However, these models require substantial computational resources and large data sets to achieve high performance. Neural machine translation, NMT, is a state-of-the-art approach that uses artificial neural networks to translate text. Unlike traditional methods that break down sentences into smaller parts, NMT processes entire sentences at once, capturing the context and meaning more effectively. This holistic approach results in more natural and accurate translations. NMT models are trained on large corpora of parallel texts, learning to map sentences from one language to another. Despite its advantages, NMT is computationally intensive and requires significant amounts of data to train effectively. The quality of a translation model heavily depends on the data it is trained on. High-quality, diverse datasets are essential for training effective models. These datasets typically consist of parallel corpora, which are collections of texts that have been translated into multiple languages. The more diverse and extensive the dataset, the better the model can handle different linguistic nuances and contexts. However, obtaining and curating such datasets can be challenging, especially for less commonly spoken languages. Data augmentation techniques and synthetic data generation can help address these limitations. One of the significant challenges in multilingual translation is handling low-resource languages, languages for which there is limited training data available. Techniques such as transfer learning and zero-shot translation can help mitigate this issue. Transfer learning involves pre-training a model on a high-resource language pair and then fine-tuning it on a low-resource pair. Zero-shot translation allows a model to translate between language pairs it has never seen before by leveraging its understanding of other languages. These techniques are crucial for making translation technology accessible to speakers of all languages. Evaluating the quality of translations is a complex task that involves both automated metrics and human judgment. Common automated metrics include BLUE, Bilingual Evaluation Understudy, and Meteor, metric for evaluation of translation with explicit ordering, which compare the machine-generated translation to a reference translation. However, these metrics have limitations and may not fully capture the nuances of language. Human evaluation, on the other hand, involves native speakers assessing the fluency and accuracy of translations. Combining both methods provides a more comprehensive evaluation of translation quality. Multilingual translation has a wide range of real world applications. In business, it enables companies to localize their products and services for different markets, enhancing customer experience and expanding their reach. In healthcare, it facilitates communication between patients and healthcare providers who speak different languages, improving patient outcomes. In education, it allows for the dissemination of knowledge across linguistic boundaries, making educational resources accessible to a global audience. These applications highlight the transformative potential of multilingual translation in various sectors. While multilingual translation technology offers numerous benefits, it also raises ethical considerations. One concern is the potential for bias in translation models, which can perpetuate stereotypes or exclude certain dialects and languages. Ensuring fairness and inclusivity in translation requires careful attention to the training data and algorithms used. Additionally, there are privacy concerns related to the handling of sensitive information during the translation process. Addressing these ethical issues is crucial for developing responsible and equitable translation technologies. The field of multilingual translation is rapidly evolving, with ongoing research aimed at addressing current limitations and exploring new possibilities. Future directions include improving the efficiency and accuracy of translation models, expanding support for low-resource languages, and integrating translation technology with other AI applications such as voice assistants and augmented reality. Advances in unsupervised learning and multilingual pre-training hold promise for making translation models more robust and versatile. As technology continues to advance, the potential for seamless, real-time multilingual communication becomes increasingly attainable. Translating text into multiple languages simultaneously is a complex but essential task in today's interconnected world. Advances in NLP and machine learning have significantly improved the accuracy and fluency of translations, making it possible to bridge language barriers more effectively. However, challenges such as handling low-resource languages, ensuring translation quality, and addressing ethical considerations remain. By continuing to innovate and address these challenges, we can unlock the full potential of multilingual translation, fostering greater understanding and collaboration across cultures.